Okay, so in lesson 9, we're going to talk about the correlation coefficient. So as we learned, the graphing calculator can help us to find what we call a line of best fit. And that line of best fit allows us to predict new values. But the question that we're left with is, how reliable will these predictions be? It would seem that the closer the scatter plots are to the line of best fit, the more reliable the predictions from the regression equation will be. The question is there a way to determine how well our regression equation fits our data? And the answer is yes, there is absolutely a way. There's a way of measuring, as we call it, the goodness of the fit. And this way of determining how well our regression equation fits our data is called the correlation coefficient. Correlation coefficient is a number from -1 to 1, and it indicates the measure of linear association between the two variables. It also will tell us whether the correlation is positive or negative based on the sign. The correlation coefficient is designated by the variable r. And as we said, it's from -1 to 1. And it tells us how good our equation is at predicting. The good thing is your calculator is going to do all of the calculations for R for you. You just have to be able to interpret it. So real quick, if R is close to 1 or -1, then it's considered a good fit. If R is 0, not a good fit. If R is exactly 1 or -1, it's a perfect fit. And that means that all of the data points would lie on the line. And as we mentioned, if R is 0, that means there is no linear relationship between the two variables. So if we look here, we have some graphs and some examples. We see here, you have this positive perfect correlation. That would mean your R is a +1. If you have a perfect negative correlation, that would mean your R is a -1. If there's no correlation, that would mean your R is a 0. Over here, we have positive and it's strong. So that would mean that our R is close to 1. So maybe it's about a 0.8. Over here, we have a weak positive. So that means our R is still positive, but it's not very good. And that would mean maybe it's about a 0.4. And you have the similar idea on the negative side. Okay, here it's a weak negative. So maybe a -0.4, 0.3, -0.3. A strong negative means it's close to -1. So it could be like a -8 or a -7. Now, to find the R in your calculator, the super important thing is to make sure you have your diagnostic on. And Mrs. Dupay is going to post a video showing you how to do that. So if you haven't watched that video, please pause this video now, and please do that to make sure that your diagnostic is turned on. Whenever you are asked to reset your calculator, like we would do before a test or a quiz, you will always need to go back and make sure your diagnostic is turned on. So please pause the video now, watch the video with Mrs. Dupay, and make sure your diagnostic is turned on. Once it is, please continue with the video. Okay, so now let's look at example 1. We have the shoe length and height of 10 men. So you're given over here, these are our X values, okay, and these are our Y values. So what you're going to want to do is take a moment, you're going to go in your calculator, go to Stat, Edit, and you're going to want to enter your X values in your L1 and your Y in your L2. Remember, make sure you clear out those lists before you enter the values. So I'd like you all to do is pause the video now and enter in your values for L1 and L2. After you've entered in those values, please continue with the video. So hopefully now you guys have your values entered in for your L1 and L2. Well, this question is asking us to write a linear regression equation. Okay, so that's the first thing we're going to do. So we're going to go, we have our values in, we're going to hit Stat, Calc. I like to use 4, linear regression model 4, enter. And you're going to see now not just your A and B values, but you're also going to see an R squared and the R. We don't care about the R squared for now, so we're just going to ignore that. So we have our A value, here will be our coefficient, our B is our constant, and our R, and that's going to tell us our correlation coefficient. And this question also asks us to find that as well. And we want to round all of our parameters, or numbers, to the nearest 10th. So you're going to take your A, round it to the nearest 10th, your B to the nearest 10th, and your R. So I'd ask you to pause the video right now. Please round your values accordingly, and then continue the video after you have rounded correctly. So hopefully you get your equation correctly rounded in standard form is y equals 3.7x plus 25.3. So remember what this means. This is your linear regression equation, or your line of best fit. And this allows us to make predictions, okay? And then this R here, this is my correlation coefficient. And remember, the correlation coefficient tells you the goodness of your line. How reliable in predicting will the equation be? Well, since it's a positive 0.7, okay, we're obviously going to have a positive relationship, and it's awfully close to 1. So if you look here, you see a basic table, and you should have an understanding of this. So when our R value, our correlation coefficient, is a positive 0.7, it asks us to interpret it. So what does that mean? Well, a positive 0.7 would fall right here, a strong positive linear relationship. So that means we have a good prediction using our equation. Now, just because our correlation coefficient tells us that it's a good prediction, please remember correlation does not equal causation. Okay? That means just because a correlation exists does not guarantee the change in one variable is causing the change in another variable. So correlation does not imply causation. So let's look at what that means in example 2. During the months of March and April, the weekly weight increases of puppies in New York were collected. So here we have the weight of puppies in New York. For the same time frame, the retail price increases of snowshoes in Alaska were collected, right here. What we're going to want to do is determine the linear regression equation and the correlation coefficient, and we're going to want to round our parameters to the nearest 10th. So what I'm going to ask you to do, once again, is you're going to take these values and sub them into your calculator for your L1 and your L2. So I would take the weight of puppies in New York, that's going to be my X or my L1. The retail price of snowshoes in Alaska will be my Y or my L2. So please take a few moments, enter the values into your calc, then determine the linear regression equation and the correlation coefficient. Make sure to round those parameters to the nearest 100th. Please pause the video to do that now. So hopefully you put all of this in your calc and you get these values for my A, my B, and my R. When I round them accordingly and write my linear regression equation, I get y equals 0.93x plus 25.09. And my correlation coefficient is approximately 1. Now remember, a correlation coefficient of a positive 1, let's look here. A positive 1, that means that there is a perfect positive linear relationship. Well, just because there's a perfect positive linear relationship, the question is this an example of causation? Does the puppy's weight cause the increase in snowshoes in Alaska? I hope you agree the answer is no. This is an example of a correlation not implying causation. I hope this video made some sense. Please make sure to finish the exercises, check them with the answer key, and when you feel confident, please move on to the homework. If you have any questions, as always, please feel free to email your math teacher. Hope you guys are doing well and staying safe. Miss you all.